When is entropy generation maximized in a thermodynamic process? Have you ever wondered why some processes seem to waste energy more than others? Today, we will tackle the question of when entropy generation is maximized in a thermodynamic process. This concept is essential for understanding how energy is used and lost in various systems. Entropy generation is at its peak when the irreversibility within a system is highest. Irreversibility refers to factors that prevent a process from being perfectly efficient. These include friction, unrestrained expansion, heat transfer across a temperature difference, mixing of different substances, and viscous fluid flow. Each of these factors contributes to increased entropy, which is a measure of disorder or energy dispersal that cannot be harnessed for work. In an ideal, reversible process, entropy generation is zero because no energy is wasted. However, in real-world scenarios, as irreversibility increases, so does entropy generation. For instance, when heat flows from a hot object to a cold one through a large temperature difference, the entropy generation will be greater than if the temperature difference were smaller. Friction between moving parts also leads to more entropy production. Think about it. When two surfaces rub against each other, they generate heat and waste energy. Similarly, when fluids flow with high friction or turbulence, it increases viscous dissipation, contributing to higher entropy generation. Entropy generation is maximized under specific conditions. First, when heat transfer occurs across a large temperature difference, it causes significant energy degradation. Second, when fluid flows experience high friction or turbulence, it leads to increased dissipation. Third, rapid or uncontrolled expansion or mixing of gases or fluids also contributes to this phenomenon. Additionally, mechanical components that experience friction or wear will produce more entropy. Lastly, chemical reactions that proceed from equilibrium generate entropy as reactants convert to products. From a thermodynamics viewpoint, the Gauss-Stodole theorem connects entropy generation to lost work potential. This means that maximum entropy generation corresponds to the greatest loss of useful energy available for work. Understanding when entropy generation is maximized is vital for engineers. It helps them identify energy losses in systems like engines, refrigerators, heat exchangers, and renewable energy devices. By minimizing entropy generation, these systems can become more efficient and sustainable. In summary, entropy generation peaks during highly irreversible processes involving large temperature gradients, friction, rapid expansion, mixing, and non-equilibrium reactions. Reducing these irreversibilities is essential for improving the efficiency of thermodynamic systems.